accounts for over 50% of the gross direct premiums earned annually. As per research findings, the total gross premium of motor insurance industry in India is expected to cross $17 billion mark by end of 2025. In this fast-growing domain, AI plays a major role in fast-tracking the claims process, reducing the manual errors and subjectivity. Saigeetha AJ has a PhD and is a senior data scientist at IBM, is a nationally recognized scientist in computer vision, machine learning, and she will be focusing on how AI-based cognitive damage assessment tool, CDAC, has facilitated the claims process from images to cut down the time selectively and the error process. CDAT has the capability to determine car make model, detect the car parts that are damaged, and identify the damage type. So let us dive into how a tool can successfully implement insurance measure for 50% or more of accuracy. Over to Saigeetha, ma'am. The QR code, please. Excuse me. This project, projection line.
Hi all, good evening. Okay, let me introduce myself a bit. Of course, she did. I'm Dr. Saigeetha from IBM. I'm a senior data scientist, and I lead a team of around 40 data scientists in IBM in developing high cognitive solutions using advanced computer vision techniques, as well as I'm also one of the architects of a platform called Cognitive Digitization. It's a content intelligence system which has the capability to intelligently extract information from documents. Today, I'm going to speak about a tool that we recently implemented for an insurance major, cognitive vehicle damage assessment for fast-tracking the claim process. In today's agenda, we'll briefly understand the business problem, then a brief introduction on the tool, and how the current motor claim process happens in the industry, a high-level process flow, some insights into the results, and then the challenges that we faced during this implementation. So, as you are all aware, artificial intelligence is the current buzzword. It's been practically been utilized in various industries. Insurance is one of the industry where AI has a huge potential, particularly to automate various business processes or fraud detection, or to identify potential clients at the right time, or to advise the clients or the customers the right products across insurance industry. So AI has been playing a major role, and we have seen this trend globally. Now India is picking up. There is a huge push from Indian banking and insurance sector in utilizing artificial intelligence, and this is just a start. And in near 5 years, this is going to grow exponentially. So in case of, this is an AI-based system, cognitive damage assessment tool that uses the advanced computer vision, deep learning, and machine learning techniques to automate the, claim process, wherein you all know, like if a car get damaged due to an accident, literally you need to give, give the images. The surveyor comes and surveys the damaged car, and then he does an assessment, gets back, and provide the amount, or advise the payment. This is a very, very manual process currently. So this is what we try to digitize. And this has been already implemented for 50 car models for 30 external car parts. The first phase is already gone on live, and it is reshaping the entire industry now. It also has an ability to identify the car make. The 50 car models in the first phase that we implemented, then it can detect the type of the car parts which are damaged, and the type of damage, and then the quantification, how much is the damage, whether it needs to be repaired or replaced. So all those, the entire end-to-end it does. So with this, what we understand from the customer, in fact, the acceptability of the the claims from the customers have grown to over 75% with this tool. Before it was around 40 to 50%. Now it has literally shot to 75%, more than that, the acceptability from the customers. Currently, around 33% of the quick claim, the quick claim settlement for personal cars is being implemented through this tool. Next. In the current motor claim process, as you are aware, if a car gets damaged, the client or the customer, he takes photographs and he actually registers with all those information to the insurance company. The insurance company allocates a surveyor who goes there, survey the damages, and then provide the settlement cost, advice on that. So this takes several hours to days for one claim to be settled, because everything is manual here. There is also a subjectivity in this. One surveyor can provide an advice in one way, another surveyor can do it in another way. So there is an element of subjectivity. So that's where this plays a major role. Currently, by automating this process, literally the entire process has come down to 45 seconds from 45 minutes to a few hours. Now the processing just takes 45 seconds. And this is actually saving huge amount of manual time as well as the efforts. Next. It's a high-level process flow. If you can see, this tool has a mobile app as its front end. As the car gets damaged due to an accident or so, the customer can go and literally take photographs at different angles and upload it in an app, and then this process starts. From the images, the tool identifies which car make is it, whether it's Maruti Suzuki Dzire or Volkswagen or whichever, those 50 car models which I was talking of. And then second step, it goes and identifies the parts that are damaged. Third step is the what kind of damage. There are 4 categories we trained the tool to identify: scratch, dent, disorientation, and breakage. So it can even detect that. And then finally, it also says whether that part has to be repaired or replaced by quantifying the damage. This is very important because it's not standard across all car parts. You must be aware of it. A scratch in a glass needs to be replaced, but a scratch in a bonnet or a bumper can be repaired. So there is a huge difference from every part to part. So you can imagine the kind of training that has gone into in getting this tool up and running. It also has a feedback mechanism. I'll also touch upon some insights into the type of feedback that it handles. So in case of the user says, if the user gives a feedback, okay, the detection has been correct, the inference has been correct, thumbs up, thumbs down, then that information is taken back through transfer learning, and then the existing models are in fact enhanced by regular retraining. So there is a feedback mechanism, and that feedback comes from the user, from the mobile app itself. Next, previous one. Yeah, So these are the three steps that I want to touch upon today, mainly from a results perspective, how some insights on how the results look like. You have car part identification. So there are 30 external car parts that can be identified, like the door, headlight, bumper, bonnet, windscreen, or etc. And there is a damage detection classification. You can clearly see the colors, different colored patterns that it had identified, scratches, even a faint scratch can also be identified. And then there is a damage quantification which says repair or replace. Next. So this is like, there are two parts of results that I want to discuss upon today. Inference on the car models that performed well, and which are the car models that performed with lower accuracy. Generally, what we saw was all the car models which are currently common in our roads, like Indica, right, Etios, kind of, which you can see common, they are best performing because of the data bias, of course. You have enormous amount of data in that front, and if you see the least performing models, previous. So you have Volkswagen Polo, or so Aspire, Ford Aspire, front runner, where the amount of data may be less. So those are the models where we had the accuracy was low. Other than that, we also had some other insights on the colors. On the cars which are having a solid finish, paint finish, like they performed well when compared to those which had metallic finish. That is because of reflection. The reflection is not standard due to metallic particles in the paint, metallic paint. Whereas in case of solid finish, it's pretty standard over there, and it performed well. Even within a solid paint, the white colored or light colored vehicles actually performed well when compared to dark colors, because again the reflection varies with the color. So there are a lot of factors that go into when we train. So we had trained thousands and thousands of images to get to this current accuracy, which is almost at 80%. It's already into production. First phase is done. It's gone online, and we are working on the second phase. Next. We saw about the car models which performed well and not performed well. Now we'll see the parts. If you can see in this particular plot, the lowest one, where these are the glass parts, right? Like tail light, headlight, windscreen, they had a lower accuracy when compared to bonnet, rear door, front bumper, quarter panel, etc. Because one, they are not glass parts. Generally, glass parts is difficult to identify, and there is huge amount of reflection that also happens. So this is also one another insight on which car parts had to be trained in a different way, which car parts are straight. Like you get a good accuracy while if you train it properly. And some of these, the parts like tires, wheels, and all, we have not taken into consideration because we had low instances of data. Next. This is a very important part on the challenges that we faced while we implement. This is a learning for us as well as to others. Because when we move from like in one of the previous speaker was talking of transforming a pilot or a proof of concept into a production mode. It's not the same. We try to pull in a small set of sample, data sample, and then try to put in some machine learning, showcase some results. That is different from implementing in a production mode, wherein real time the accuracy is measured or the performance of that tool is measured. So that is completely different. And these are some of the 4 challenges that we saw. First one is the reflection. It's a very, very common issue that had played a major role in accuracy impairment. We did some to mitigate this, we did augmentation of data with various levels of illumination for different car colors with different models. So we, in fact, generated the data here because the data that we got from the customer was highly biased. So to mitigate that, we in fact generated the data with using advanced computer vision techniques. Second one, images captured in uncontrolled environment. People can, it's very common. People can click photograph in a very, very dark environment, and it's even hard to see. So those kind of images were pretty high. Even though there, we trained to, wherever we could enhance the data, we did using image computer vision techniques. But we are also working with a system-generated feedback mechanism where the system itself would decide whether that image has to be used or not. So it's a feedback within the system. It checks the data quality. It says whether it can be enhanced, how much it can enhance, and what kind of enhancement it has to do, whether to deblur it, reorient, or whatever, it decides, and then gives the feedback back to the system. The system decides, okay, I'll do the enhancement to this level, but if the quality is too low, reject it. So that is the kind of system-generated feedback that we are currently implementing, and this has been quite successful in those type of issues. Okay, there are two more, which are very, again, common issues that we faced. We did using augmentation of data. Again, that is one major work that we did to generate the data itself. So if you have less data, don't worry, generate it. You know how the data would look like, so generate the data and enhance your accuracy. Way forward. So the current plan is to extend this tool with 20 more additional external car parts, and then we would be also increasing from 50 car models to 60. That is again in the second phase that we are working on. This particular tool would also be extended for pre-inspection cases, fraud detection particularly. That is the last one. In fraud detection, there are two, possibly we are looking at mitigating two ways. One, identical people can claim for the same damages twice, right? That kind of, that's a very common fraud. So here, with this tool, we can identify whether the claims are identical and identify the fraudulent case. Second one, within a claim, we get multiple images, whether those all belong to the same vehicle or not. So those kind of different fraud mechanism, detection mechanism we can work out. It can be extended. And then I spoke about the feedback. There are two types of feedback. One is the system-generated feedback, which for enhancing the data, which I spoke a bit. Another one is the user-generated feedback for enhancement of your models. So all these are done through deep learning networks. In every stage, deep learning networks were used. And it is currently running in a GPU. We are also planning to have it on IBM Cloud going forward. Yes, that's it from me. I want to keep it short. I know that we are running out of time. Thank you. Thanks for your patience. And any questions I can take up. Have any questions?
We have questions, so we'll just take one for the matter of time. So one of the questions that we got is, does this tool also analyze internal damages?
This tool currently analyzes the external damages only. We are planning to extend it for internal. Once the external parts are completed, we'll be taking it for internal damages as well.
Okay, thank you so much. It was indeed a cool utilization of AI ML, because car insurance is such a hassle, not only for the car insurance people, but also for the person who undergoes, and he has to have multiple claims for the damage. So thank you so much for shedding light.
Thank you. Thanks for your patience. Thank you. Thanks for calling me as well.
So this was the QR code for the current session by Saigeetha. So you can scan it and you can input your feedback, you can give your ratings, you can also ask questions which will again be redirected to the speakers. So in the speakers app, actually we are sending out all the questions that were asked against that session so that the speaker can in fact reply back to those within the app itself. We will now move back to the session that we left before the tea break, the need of the hour for ever-changing skills economy. We have two panel members who will have their separate talks, one after the another, so that we can understand the need of the hour in ever-changing skills economy. First up, we will have Pranali Save. She's the CHR of our iCertis, and she will be dispensing her expertise and advice on how to stay relevant from a business standpoint for companies of today. I welcome Pranali onto stage.